Hello everyone and welcome. My name is Tim Paine. I'm a developer at JP Morgan in New York City, and today I want to talk to you about production notebooks. So just as an overview of today's talk, I'm going to start with a little background on JP Morgan and one of its software platforms called Athena, as well as details of Athena's Jupyter deployment. Then I'm going to jump into how do we leverage Jupyter, some of the infrastructure that we use to support its deployment, some development methodologies we've built around it, as well as some notebook-derived applications and tools that we've built. And finally, I'm going to get into the meat of the talk, which is really software lifecycle and software libraries we've built to support safe notebook use in production. And I'm going to clarify what I mean by notebook use and what I mean by production at a later point in this talk. So just for background, JP Morgan Chase is one of the world's largest banks. JP Morgan is the investment banking side, Chase is the commercial and consumer banking side. We have over 40,000 technology employees globally. Our annual technology budget is, around $10 billion. So it's a massive technology organization with many different teams working on many different problems. Within JP Morgan, the investment bank side, one of the largest software platforms is called Athena. So it is a Python-based platform. There are around 2,000 developers working either on Athena itself or within the Athena ecosystem. There's around 40 million lines of code in the code base, organized as a monorepo. So it's a massive platform. We have, 1,000 plus open source packages, Python libraries, C++ libraries, Java libraries, things like that. And we have hundreds to thousands of production code releases per day, people pushing code to production. So it's a massive and extremely dynamic platform. If you're interested in any of the details of the platform itself, that's not the topic of today's talk, but there's a great talk with slides from PyData 2017 in New York City called Managing Python at Scale Without Breaking the Bank. And that dives into a little bit of the, the tools and SDLC and infrastructure and basically how do we keep this platform running while still enabling it to be dynamic. So feel free to look at that if you're interested more on the platform itself. For me, my team is called Athena Research. It's within the larger Athena team, and we're responsible for our Jupyter deployment, as well as lots of analytics applications, sort of AI and machine learning tools and libraries. Really anything that's open source and up and coming, we'll investigate, develop, integrate, deploy, do whatever we need to do to leverage it. And for our Jupyter deployment, our primary platform is a hosted instance that serves thousands of daily users globally. Most of them are business users or quantitative research, basically people not in a development role, which brings with it all kinds of interesting challenges. If you're not familiar with the internal structure of an investment bank, the different businesses here doesn't mean too much to you, but suffice it to say, we have a lot of people coming from a lot of different backgrounds, working on a bunch of different business problems all around the world. So how do we use Jupyter? We run Jupyter in production with 3 target deployments. So the first is the obvious one. It's basically Jupyter itself. We have a Jupyter hub style platform. It's a single deployment for around 1,500 users. We make the libraries available for them to run locally, but generally people prefer the convenience of just opening a tab on their browser and getting a new Jupyter instance running on some cloud machine somewhere. The second one is static reports, so notebook-derived reports leveraging NB-convert and papermill to create PDF or HTML or email reports. And we're running hundreds of those daily, and that sort of the number of reports that we're running is increasing every single day. We also run live applications based off of notebooks using the popular Voilá library. We have around 50 of them currently in production and over 100 in development. So Athena brings with it a lot of tools and infrastructure to help us in our Jupyter deployment, and 2 that we rely on very heavily are a scheduler that supports both batch jobs and high availability jobs. For the batch jobs, we might leverage those to run our reports on some predefined interval or at some daily time. For the high availability jobs, we use that with Voilá to make sure that the Voilá instances are running in all of the regions on all of the machines that you expect them to be running on. The second thing that we leverage is a distributed replicating object store. And this is used for both data and code. It allows you to look at different slices. So I might be able to look at like a development slice with a production layer underneath. Basically makes it easy to collaborate and to work on, different projects. And so, the distributed and replicating nature of Hydra makes it very nice. If you save a notebook in New York, it's almost immediately available in Tokyo. When we run deployments of either Voilá applications or these reports, everybody can be looking at the same code or the same data globally, no matter where or when the code runs. So I'll take the time now to clarify, what do I mean by production? So for this talk, instead of focusing on the Jupyter Hub deployment, because that's, the state of the art is open source and the details of how we actually do that are not particularly interesting. Most of those things are sort of well explored in the binder or, Jupyter Hub projects. I'm going to focus on the production report side of things. And when we say production, we really mean that me as an individual business user, an individual developer writing a notebook, I come to a certain point where I want to share that notebook with other people. And generally, when we're talking about production, we mean that you want to share that notebook with non-technical users or people looking at it outside of a notebook interface. The most common question that we get when it comes to, when it comes time to deploy a notebook is, can I just hide the code and see the outputs? Also, alongside, production notebooks, that generally means running the notebook in any type of automated fashion. So it might not mean generating a report or running a Voilá application, but it might mean making sure that notebook still works with the code changes or library changes underneath. So obviously, we want to have a production notebook. Implicit in deploying a notebook to production is that the notebook is stable, that it's testable in some form, it's deployable in some way, and that it's extensible. Alongside these things, we want to kind of, when we're talking about production notebooks, we want to encourage best practices. So we want to avoid a lot of the pitfalls and anti-patterns highlighted in the popular talk from last JupyterCon called "I Don't Like Notebooks." So when we're talking about production notebooks, we mean these are no longer scratch pads for quickly iterating or experimenting. We're really using these tools to bring some libraries together with some data and present it all together with text and markdown. And for us, we generally encourage that, you get to a certain point in the life cycle of a notebook where the actual libraries that you're writing should be pushed down into our more full-featured IDE. One other thing, when we're talking about production notebooks, we generally mean linearly executed notebooks. And this is one thing that's highlighted, very extensively in the I Don't Like Notebooks talk. When you're talking about running a notebook in an automated fashion, you generally mean it's executed top to bottom one time. And this is true of both our static reports as well as Voilá applications. So let's get into the real content of the talk, which is the software development lifecycle and software libraries that we've written to deploy production notebooks. All right, so we're going to again be focusing on the report side and the Voilá applications side. The real question, the real problem that we're trying to solve is, with all of these applications and these two deployments, how do we stop them from breaking in a code base that might update hundreds of times per day with open source libraries constantly changing underneath them? And the solution that we've come up with under active development, of course, is called nbcelltests. So nbcelltests is a library that we basically have written to support linting and testing notebooks. I want to take a moment just to look at some prior art because I think it's important to highlight these things, but also because we use them in our library. An important one is called nbval. It's predominantly targeting reproducible notebooks for scientific research, and it compares the stored outputs of a notebook with the outputs generated when you rerun the notebook. It integrates very nicely with PyTest. For us, we couldn't use this library off the shelf because we have a couple of problems unique to our deployment. One, we can't always store the outputs. So if there's sensitive data in the outputs, or charts or anything like that, we might want to purge that prior to saving. So we might not have that available to us when it comes time to run nbval. Secondly, almost everything we do is temporal in nature. Prices today and prices tomorrow are going to vary. So it's almost never the case that we expect the outputs to match, right? We expect those to be changing every day. And we want a library that can where we can structure tests to take that into account and kind of simulate what are today's data supposed to be, and we can test against that. So another prior art, though it's really concurrent art because it's also under active development. All of these are under active development. I think nbval was probably the first one, is called Testbook. So Testbook is a very promising library which lets you kind of extract and unit test cells, which is a very similar type of functionality that we want. We'll likely integrate with this library in the very near future, but for now, we really want to be able to do invasive mocking within the cells of our notebook to really make sure that we're fully unit testing what's getting done. And it doesn't quite allow for that yet, though it looks very promising. So nbcelltests brings with it two main features. The first is linting, and we're really targeting notebook structural lints. And I'll highlight what this means in just a second. We also allow for cell-by-cell testing, so cell-by-cell unit testing. So taking into account, the pitfalls of developing in a notebook, this library encourages or enforces best practices through these structural lints. And it enforces this idea of, single run top to bottom execution through these lints. These lints are designed to basically enforce that if you're writing too much code in a notebook, if you're trying to build libraries in a notebook, that this is a bit of an anti-pattern and it introduces a lot of danger into the notebook, especially in such a dynamic platform. So we want to prevent it if possible. So we can lint our notebooks for things like the number of lines in a cell, the number of cells in the notebook, how many class definitions or function definitions are you doing in a notebook, and these are sort of high signs that you might be doing too much library development in the notebook itself, and that stuff should be pushed maybe into a Python module where our tooling is more extensive around that. We can also lint for things like the kernel that you're using, any magics that you're using that may or may not be safe outside of a notebook context. So in something like a report or in something like a Voilá application. And of course, we allow you to kind of export your notebook to a Python module and run a traditional Python linter on it. Cumulative cell testing, which is the other key feature of nbcelltests, lets you write tests around your cells. So for each cell, we generate a test that builds on the previous cells in the notebook. And it's structured in such a way that it lets you sort of run a pre-cell hook and post-cell hook. So let's just take a look at a little bit of sample code to show this. So in this sample code, I've got like some module, let's say, that I'm using. I can patch using just a mock, some function call that I'm doing. Then we allow for a special cell magic, which is this %cell, which basically means insert the contents of the cell at this location. Right, so this lets us do some stuff before we execute the cell, do some mocking. Maybe we're doing a database call, or maybe we have some sample data that we're gonna inject into our, we're gonna mock something to return some sample data. We can then run our cell to kind of pull that stuff in. And then afterwards, we can do some assertions to validate that exactly what that cell is supposed to do, executed as expected against the mocked out data that we've injected. And these cells stack up as you execute the notebook. So, future cells build off of the results of previous cells. So it lets you really unit test each individual cell to a really deep degree, as well as ensure that your notebook's total functionality is what you expect. These linting and testing, these two major functionality, we can then integrate into our IDE, which we have. All notebooks that are going to go to production, so you want to deploy a production scheduled job of some static report, we obviously enforce that you pass some set of lint rules. For these structural things, we might enforce no more than 10 cells in your notebook. And any tests that you write, we want to make sure that those pass. In addition to having to pass before you go to production, as libraries change, as your dependent code modules change, we continually run those tests and we'll send you alerts if things fail. Last little thing I want to highlight, we leverage a lot of state-of-the-art open source here. notebooks, when they're presented under VC, will just show you diffs with JupyterCon, so make it a little bit easier for you to look through them. So I want to take a moment to just take a look at nbcelltests in action, and we're going to use a front end that I've built for it for JupyterLab, a JupyterLab extension for it. And I'm just going to write a little bit of dummy code. I'm going to import pandas. I'm going to, make a data frame, show the grid, and then what I'm going to do is I'm going to write a cell test for that little bit of code. So I'll mock out one of the calls with some sample data, inject my cell in the cell test, and then validate that the data is what I expect it to be. And the idea here is if that was a database call or some temporal data, we can kind of validate that exactly what our cells are doing is correct. Finally, I'm going to just show the linter in action, and I'm going to tweak some of the rules, the lint rules for my notebook, and run them. So let's just get into it. So I'm just going to create a new notebook, as I said, where I just create a pandas data frame, and I'm going to use one of their utility libraries at pandas.util.testing.get time series data. It just returns some dummy time series data. So here I construct the data frame, and let's just take a look at it. All right, just a normal data frame, couple of columns, and I'll just create a seaborne heat map here just for fun. Off the column correlations. It's all randomly generated data, nothing super interesting. So if I pop over to the Notebook Tools tab within JupyterLab, we'll see the cell tests interface. So markdown cells don't have testing yet. We don't know if that's something we want to do in the future. So let's just focus on a code cell for now. I'm going to mock out this pandas util testing get time series data, and I'm going to have it just return some dummy data. So I'm going to patch it using the mock library, have that return some of my dummy data, just, a list of dictionaries, whatever, some different data. Then I'm going to use that special cell magic to inject my cell. And finally, I'll assert that the data contained in the data frame is equal to the dummy data that I've done. All right, let me save that. All right, so just a little test to show that we can do this mocking in this kind of invasive mocking. When I run these tests, it'll run them under PyTest in that cumulative fashion. So we'll see 4 cell tests running, everything passes as expected, great. And we can obviously run these things offline. Once we've written the tests for a notebook and kind of saved them, keeping the whole notebook asset together, the tests and the code alongside each other, means we don't have to worry about them getting disconnected. We can then plug this into, as I said, the IDE can run tests. The sort of SDLC commit push process can have this hooked in. And we can run them on some scheduled fashion so that code changes, library changes, we can check at a very granular level if these affect your notebook. So the last thing we'll do is look at some of these structural lints. So these are available from the same tools menu. So let's just put in a new lint saying that we're limiting the total number of cells in our notebook, and let me limit it to 3 for now. Then I'll pop back over to the command palette and run my linter. So obviously this fails, and we can integrate this with our IDE or with VC like anything else. And it fails because I had 4 cells in this notebook. So let me just quick tweak it to 4, rerun the lint, and we'll see that everything passed. All right, so just like our tests, we can hook this into our IDE, we can hook this into this ongoing SDLC process. And with these lint rules, one thing that we can do is, obviously they're exposed in a notebook for you as an individual, just as an end user, to be able to kind of play with them. But in our enterprise deployment, we make these things sort of centrally overrided, so we can enforce that across the whole organization. Nobody's defining too many classes or too many functions in the notebook. And this is all designed around enforcing those best practices. Linearly executed notebooks, pushing code wherever possible into modules where we have greater developer tools around them to kind of, we can build, in many cases, better tests around the Python libraries than we can around the notebook themselves. We can enforce different linting rules, some better linting rules around those. All of these structural lints are designed to encourage, or in some cases, enforce that. So that was a brief overview of this nbcelltest library. It's available on GitHub under the JP Morgan Chase account. It's under active development. We're still working on it. There's a lot of work to do with the front end, hooking that in. We also look to kind of partner with some of these other open source libraries so that we're not doing the same thing over and over again. So please do check it out. We're leveraging it right now in production for development. Take a look. So I'm just going to highlight a couple of other libraries and other things that we've built or other people have built that help us run, these static reports and these Voilá applications more smoothly. These are not necessarily things that we've developed, but they're things that we find help us ensure the sort of stability and general functionality of these deployments. So one thing that we leverage a lot is a custom tweak to Voilá, which lets us run things and inject things into the notebook. So we can basically inspect the tornado request. If you don't know how Voilá works, it's basically a sort of sharded single user notebook as web app. So we can basically look at the web request, do some authentication, user impersonation, logging. We do a lot of logging across all of these deployments just to kind of look for things going wrong, look for weird problems, and be able to kind of figure them out and fix them as quick as possible. We can also do some production validation and some UX, some UI stuff. So let's take a couple of looks at it. This is currently a PR on the Voilá repo. So we can do some cool things like, and we leverage templates as well. We've got this kind of launching indicator. We can do things where the notebook has some functionality to detect, am I running in a production environment? Am I running in a non-production environment? Library versions, I can send emails, things like that. We can kind of inject that ability. We can also do with templates and with the pre-launch hook, some disconnect alerts, some things like that. So it's a very helpful library, good for end users who aren't going to want to see like a stack trace. Another JP Morgan library that we've written is called JupyterLab templates, and it basically lets you take a notebook and use it as a template for other notebooks. It's good for sharing some boilerplate, again, encouraging some of these good patterns and best practices. You can save templates for your whole team. And that's available on GitHub under the JP Morgan Chase account. One thing that we do a lot is we've wrapped some of the default Python kernels. So with some slight modifications, you can do resource limits on top of IPy kernel. So here's a very short example. In something like a Voilá deployment, maybe you've got a machine that you're running it on, maybe there's other jobs running on that machine. You want to be able to restrict resource allocation. So here I just throw in some CPU limits and some memory limits, and then I defer to the IPy kernel instance. So it makes it very easy to kind of control your deployment. And we leverage this extensively because all machines always have more people wanting to work on them than there is CPU power. It's also useful for collecting stats and injecting logging, and so that original stats page that I showed earlier on in the talk was powered by some of these injections that we do. P2P copying in JupyterLab is another thing that we do that's very helpful. It's often useful to copy from person to person. Maybe you don't want to deploy a Voilá application just to share a notebook between two people. This kind of helps us know when not to deploy a notebook. And with that distributed object database underneath, it's very easy to copy from the slice that I'm looking at to the slice that you're looking at, or for us to both look at the slice underneath. And we just have a little lab extension that lets us copy these things around. We can copy it from one slice of Hydra to another slice of Hydra. And finally, this isn't something that we use because for free, Hydra gives us a log of every save of every notebook. But just to get some of that same functionality without the deployment of Hydra, I've written this JupyterLab auto version library. And basically, it just transparently commits every save of a notebook to a backing storage mechanism and lets you revert through time. So that's also on GitHub. It gives us some of the same functionality of Hydra, but for non-proprietary, non-Athena users. So that's the talk. My GitHub is Tim K. Paine. The main library here, this nbcelltests library, is available under our JP Morgan Chase GitHub account. I encourage everyone to take a look, file bug reports if you can, use it. And for other people interested or currently deploying Jupyter at scale in enterprise, take a look, see if it integrates into your SDLC practices. And as always, let me know if you're interested in collaboration. Thank you everybody for listening, and have a great day.